Hi friends, good morning. This is Manish Khandeval. I am a mechanical engineer and the details of my experience are mentioned at the bottom of this slide. As you can see, today's presentation is on Xbar R chart. Friends, if you recall, I have given a presentation on SPC in the month of May in two parts. In the second part, I have presented the interpretation of control chart made with some observations. I had also tried to explain as to how to do the calculations to find out upper and lower control limits. There are few other things in that presentations like calculation of CPCPK and its interpretation, preparation of Pareto chart and fishbone diagram. Last week I had posted a template for Pareto chart. This was to make work easier for those who need to make, present and analyze the Pareto chart very frequently. Similarly, this week also I am presenting and attaching a template for Xbar R chart. This again is to support those who need to make and present and interpret Xbar R chart frequently. As has been mentioned in this slide in red fonts and few subsequent slides also, I have given a link in this video description. As shown in this image, when you will open the presentation, at the bottom side you will find that the name of the presentation is there, and just below that you will find the link. Please double click on this link to open the Excel sheet, which is a template for Xbar R chart. You will find that you will need to fill only the dates and observations, and rest of the things shall automatically be calculated, including preparation of charts. Friends, I actually posted this presentation yesterday, and after a few minutes I found that this template I was not able to open it. So I have just rectified few errors and now again I am reposting it. For Pareto chart also, I think the template for the Pareto chart I shall again post it for the benefit of the people. Friends, just a very brief on control chart. Control charts are used to monitor and understand the behavior of a process over a period of time. Then control charts help us identify the trend, patterns and variation in the process. And once we know it, then of course we know the areas of improvements and how to make our quality control more effective. Let us recall as to how to calculate upper control limit and lower control limits. There are two methods to calculate upper and lower control limits. One is using the standard deviation and second is dispersion or range. The formula for calculating the upper control limit by standard deviation is to multiply the standard deviation by 3 and add it to the mean value. And if we subtract the 3 sigma value from mean value, then we will get the lower control limit. This method is used when the dispersion in the process is desired over a long period. In this method, normally a single reading is recorded at a time, or in other words, we can say that only X bar is calculated and X bar is considered, not X double bar here. To calculate upper control limit and lower control limit by range method, we need to calculate the X double bar. 2 times we have to take the average of the readings. And then after that we have to select the constant. This constant is selected based on the sample size. This constant is multiplied by R bar. R is the range. After that, if we add X double bar and multiplication of A to R, we get the upper control limit. And if we are reducing the value of A2 into R bar from X double bar, we will get the lower control limit. This method actually is used when we have to detect the large variation. In this 3 to 5 observations are recorded at a time, and then we take the average. As you can see here, we take X double bar. Here it was X bar, here it is X double bar. An Excel sheet is embedded here. This is the template where you have to feed the date and the observations you have made. After that, you will automatically get the graph made. You will get the values of X double bar, range, you will get the value of 1 sigma, 2 sigma, 3 sigma, all these things you will get. So this is the template. An example is given. Of course, this is the actual example which is taken in the template. This is for the standard deviation method. Only single value, as I said before, also only single value is observed. After that, we have taken the mean value. You can see the mean is same. It is same. And then, of course, upper control limit is calculated. How? We need to calculate the standard deviation first. Once we calculate the standard deviation, then we multiply it by 3 and add it to the mean value, this value. So standard deviation multiplied by 3 plus mean will give us the UCL. Accordingly, mean plus 1 sigma, mean plus 2 sigma, mean plus 3 sigma, all these values are mentioned, and accordingly mean minus 1, mean minus 2, mean minus 3. A graph is given on the next with the readings we have taken before. This is the actual graph actually we'll be making. And how to interpret the control chart, we have discussed it before also, that if 6 or more points are in the increasing or decreasing order, then this is a point of concern. Again, 4 out of 5 points, if they are falling between 1 and 2 sigma, then also this is a problem. Similarly, if half side of the mean, if there are 8 or more consecutive points, then it's a problem. Similarly, if there are 2 or 3 points between mean plus minus 2 and 3 sigma, then also it's a problem. And anyway, if any reading is out of the control limit here or here, anyway, this anyway is a point of concern. So this is how we'll interpret the control chart. Interpretation, of course, I have already presented in my last SPC part 2 in the month of May. This is to calculate the UCL and LCL and make the control chart using the range method. This also is actually from the example only, which is given in the Excel sheet I have prepared and embedded here. So you can see that we are taking here 5 readings, whereas in standard deviation method there was only 1 reading. So there are 5 readings, then we take the mean of this reading. So this is 1 bar, and then of course after that all the readings, all the X bar, we again take the mean, that is called X double bar. Similarly, we take the range, the maximum minus minimum here, the range, and then of course we take the average of that becomes the X R bar. This is X double bar. Accordingly, we calculate the upper control limit. If you can recall, it is X plus A2 bar. So A2 is calculated, this is a constant table. A2 is for, this is 5 samples, so we just take in front of 5 is 0.77. So this value we take, and then D3, D4 value also we take based on the table. And then of course the X bar chart and R bar chart are made. These charts are automatically made, and the template you will be using will be supporting you on this. So that is all in this presentation, friends. Hope this template will also support you, and it will make your work easier. It will save some time for you. If you have any other suggestion, please let me know. Those who have not subscribed my channel, please do so to get such help faster. Thank you.